Hello everyone, I am Elvis from the Buni Program. In today's video, we'll explore some exciting projects you can create using the Smart Home Kit. The kit includes 20 step-by-step project guides, and it's a great idea to start with the basic before moving to more advanced projects. Let's jump in and code your first project. We're going to learn how to control an RGB LED using a push button. A push button is a digital input device that completes a circuit when pressed. When you press the button, it connects two pins inside, sending a signal to the microcontroller. We use this button to trigger events like changing the colors of the RGB LED. RGB stands for red, green, and blue. This LED combines three LEDs into one casing, allowing us to create almost any color by mixing the three basic colors. We control the brightness of each color using PWM, pass width modulation, which let us blend colors like purple, orange, or white. To begin, let's wire everything up. Connect your push button to pin 4 on the ESP32. So I'll check the push button and do the wiring. So I'll put the signal pin to be red in color, like that. And then we'll go to our ESP32 and connect it accordingly. So put it to pin 4. So we also want to connect the RGB LED. It has 4 pins. So I'll put the ground to be white in color. And this one normally goes to pin 16, 33, 19 in the ground. So just connect that. Okay, so once everything is connected, we need to connect our ESP32 microcontroller with a USB cable. So we connect the other end to our computer. In this tutorial, we're going to use the Arduino Cloud, which is an online version of the Arduino IDE. To begin, head over to your regular browser and search for app.arduino.cc. It's my first option here. You'll be required to log in with your Gmail. If you're a new user, you need to create an account, and it's simple. For new users, you'll need also to configure an agent, which is available in the documentation. But I'll send a link so that you can get started easily. So when you log into the Arduino Cloud IDE, you will have sketches. So sketches are files where you can write your code. And for me, you can see I have several projects because I've been using it. Yeah, so that's how you normally get started. So when you click on sketch, you can create a new sketch. In the new sketch, you can put now your already written code, depending on the project that you're working on. So basically, this is how it looks like. You have your coding environment here, similar to what we had in the Arduino IDE, which is offline. Yes, and then you can select whatever board that you want from here. You can upload your code and also verify if your code is working correctly. If you need to add libraries, then we have these options here. Click on the library and you search for that particular library that you want. Also, you can add libraries as zip files if you also want by clicking on this up arrow. So this is Arduino cloud environment. I already have the pre-written lines of code, and we'll be working with the LED and the push button. So let me just explain the code step by step. This code controls an RGB LED using the ESP32 board. When you press a button, the LED lights up in red for 1 second, then green for 1 second, then blue for 1 second, and finally turns off. The code uses a special trick called PWM in full pulse width modulation to mix colors smoothly. It's a simple way to learn how buttons and colored LEDs work with microcontrollers. To get started, we'll define the pins that we'll be using. As you can see, pin 16, 33, and 19 have been configured for the RGB LED. Then we mounted the button on pin 4, and that is what we specify in the code. Secondly, we need to define the PWM channel, which are 0, 1, and 2, that will be glowing different colors, red, green, and blue. And then on the void setup, it's all about defining the pins that we'll be using. So the first one will be the red pin, configured on the red channel at 5 kilohertz PWM. This is done similarly on the green channel as well as the blue channel. And then we specify the button in which, the pin in which we have mounted the button. Finally, for the LED to go on and off with different colors, we need to define that on the void loop. So when the button is pressed, it will light red for 1 second, green for 1 second, and blue for 1 second, and eventually it turns off. Now it's time to program the microcontroller. Just select the board. Yeah, so our board is ESP32 dev module. Then we can upload the code. So with that done, we can press the button. And voila, you just automated your first device. You can press it again, and you can see the colors are lighting as the way we explained it in the code. Now, let's take it a step further. What if you could control your light with just a clap? Let's add a sound sensor to the mix. So here's the sound sensor that we'll be using. It normally has several pins. The microphone has 6 pins. 3 volts and ground are used for voltage input. Bit clock tells the microphone when to send the next bit of data. Data out, it sends the pulse density modulated depending on the configuration. Left-right clock determines whether the current data is for the left or right audio channel. Select is used to determine whether the microphone outputs left or right channel data. So on my microcontroller, I've already searched for those pins and mounted my female to female jumper cables. Yes, so we'll just do it orderly. The last pin. Okay, so we are good to go. I'll update the link to access this code on the description. So right now we have the RGB LED, we have the button, and finally we have the microphone. So we want to turn on our LED by a clap. Now, we have a sketch file that will enable us to control the RGB LED by using claps. For us to understand this sketch better, let us do a small review of code 1. In code 1, we used a button. When pressed, it changes RGB LED color from red to green to blue, and then it turns off. Now in code 2, I've replaced the button with a microphone that detects the loud sound. If the sound is louder than a set value, the RGB LED lights up. Let me explain this script so that you can understand the mechanism. From line 1 to 4, this part loads special libraries that let the ESP32 talk to the digital microphone using the I2S, which is a fast way to read audio signals. From line 6 to 7, we added a buffer to temporarily store the audio samples from the microphone. From line 9 to 10, this is the noise level. If the sound is louder than 8000, the LED will turn on. From line 12 to 17, this code sets up constants for configuring the RGB LED using PWM, where each color is assigned a specific channel, and the PWM signal operates at a frequency of 5000 Hz with 8-bit resolution. From line 19 to line 37, this sets up how the ESP32 reads data from the microphone, including the sample rate, bit size, and which pins are connected to the microphone. From line 42 to 47, this line starts the microphone and tells the ESP32 where to get the audio from. From line 49 to line 55, this code initializes PWM on 3 channels for an RGB LED with a specific frequency and resolution, and then links each channel to its corresponding LED pin. Read audio data. This function reads sound data from the microphone and stores it in our buffer, process audio. This one removes background noise and calculates how loud the sound is. Control LED is the decision-making part. If the sound is loud, it turns the RGB LED on. If not, it turns it off. Finally, set color. This function sets the color of the LED. Here, I use a soft mix of red, green, and blue. You can change it to any color you like. In summary, instead of pressing button like before, we are now using a loud clap or sound to control the LED. The microphone is our new sensor trigger. Go ahead and upload your code and see the results. With just a few lines of code, the LED can turn on and off when you clap. Your creativity is your only limit. Want to go even further? Let's bring in a few more sensors. You can display temperature and light levels on the OLED screen, all while still controlling your RGB LED. Connect the OLED display, the light sensor, and the DHD sensor like this and update the code. Now that you have mastered lights, it's time to level up your smart home skills. In the next video, we'll build a smart lock and you'll learn how to control a servo using a secret code. Let's crack some passwords. If you found this video helpful, give it a thumbs up, share it with a friend, and don't forget to subscribe to the Buni Program channel for more exciting tutorials. Hit the bell icon so you never miss a project.